It's really y in disguise, okay? So f of x is really y in disguise, okay? And what I want to talk to you guys about today is that fractions are really something in disguise. Did you guys know that? Yeah, they're really decimals, or actually just really even division, right? Because whenever you put, like, in your calculator, if you wanted to know what 3/5 is, wouldn't you just do 3 divided by 5, right? So fractions are really just division in disguise. So we're going to talk about fractions and division today, okay? I want you to go into your notes, and I want you to fill out some of these as much as you can. Do you guys, I want to skip the first one. Do you guys know what the ln of e to the -1 is? Because ln and e are actually inverse functions. So it's kind of like if I said, 3 squared and square root. If I did the square root of 3 squared, what do I get back? 3. So since ln and e are inverse functions, what do you think I get if I do the log of e to -1? You get not just 1, but -1, okay? What do you think the log of e to the x is? X. What do you think the log of, well, let's do this one down here. What's the log of e to the 5th? 5. What's the log of 1 over e squared? Very good. This is -2. Okay, do you guys see where the -2 came from? Well, if you rewrote this, isn't that really e to the -2? Do you see that? So you rewrite it and you see, oh, that's a -2. The other way that you can think about this is, I'm having a little trouble with my pen, but the other way you can think about it is this way. When you log a tree, the cat falls out, right? It's just nature, right? This is a log, and e rhymes with tree. You have to use your imagination a little bit in calculus. So the cat falls out. So when you log a tree, the cat falls out. And so over here, I have to turn this into a tree, and the cat falls out. What's ln of e 1/4? 1/4. What's ln of e? That's a tricky one. Yeah, well, where is the cat here? He's actually not 0 here. He's actually 1. Does that make sense? And so this is going to be 1. So this answer is ln of e is going to be 1. Okay. Let me ask you this one. This one's kind of a tough one. What's the ln of 1? What's the ln of 1? Close. Okay, let's try this again. What's another way I can write 1 in terms of e? Isn't that ln of e to the what? 0. So now what is it? It's 0. Okay, so ln of e is 1, but ln of 1 is 0. Okay, just to make things confusing. You have 2. Yeah, well, isn't ln of e to the 0 the same thing as 1? Right, so that's 0. So that's why both of these are 0. Okay, guys, what about graphs? I want to make sure you guys can graph these. If I wanted to graph ln of x, do you guys know what y equals ln of x looks like? Okay, it looks like this. Okay, and you need to know that this point right here is actually 1, 0. And does that make sense? If I plug in 1 here, don't I get 0? Right, if I plug in 1 right here, don't I get 0? Right? And over here, I also want to make sure you guys can graph e to the x. E to the x looks like this. Oops. Okay, this is e to the x. This is y equals e to the x. Okay, I want you to notice some things about e to the x. No matter what numbers you plug into e to the x here, you're always going to get a positive number. Watch this. If I plug in -5 right here, if I plug in -5, wouldn't this point right here be e to the -5, right? Well, what's e to the -5? Isn't that 1 over e to the 5th? Is that positive or negative? 1 over e to the 5th. It's positive. So even though you have a negative exponent, I want to make sure you guys understand, even though you have a negative exponent, the number is positive. Okay, this is where we start getting a little bit confused with e. And I get a little bit confused too, especially since my pen is not working. Okay, so I want to make sure you guys know this point here is 1, 0. But since these are actually what we call inverses of each other, this point is actually 0, 1. Okay, when functions are inverses, they have what I call corresponding points. I don't actually know if that's a technical term, okay, but I call it corresponding points. If you have a 1, 0, then you have a 0, 1. All right, I want you guys to put some numbers in order for me, okay? So let's start with these numbers here. I want you guys to put these numbers in order, okay? 0 is here. Do you agree that 3 to negative 1 is really 1/3? You guys okay with that? Now, this is kind of interesting. 3 to negative 1 has a negative, but it's not a negative number. You guys good with that? 1/3 is not a negative number, even though it has a negative here. All right. This is 1/9, right? This right here is 3 raised to the 1/4. So that's the cube root of 3, right? Which if you put it in the calculator, I think it's like 1.6. At least that's what someone told me in 4th period, but they lie to me just like I lie to you. I guess it's fair. Is it about 1.6? Something like that. Okay. And 3 to the 5th. What is 3 to the 5th? Isn't that 81 times 3? I'll get a calculator. Is it 243? Yes. Okay. So that's 243. Oh, 1.3. Thank you. See, they did lie to me. Okay. And then this right here is 1. Okay. So let's put all this in order, please, from the smallest to largest. Smallest to largest. Okay, so if I put it from smallest to largest, I think this is the smallest to largest. And let me change it to 3s. So this is really 0. This is really 3 to negative 2. This is really 3 to negative 1. 1 is really 3 to the 0, right? This number here is really 3 to the 1/4. And this number here is really 3 to the 5th. Okay, so I'm going to change it all to 3s. So I can see in relative order, okay, if I'm just looking at the exponents, okay, do you agree that the bigger the exponent is, the bigger my number, right? And the smaller the exponent, the smaller my number. Everybody good at that? And it works just like the number line. So if negative 2 is less than negative 1, then it's going to be smaller. Then 3 to negative 2 is going to be smaller than 3 to negative 1. Okay, we agree on that. Okay, why in the world is 0 over here by itself? Like, why isn't 0 in here somewhere? All these numbers are positive. Do you agree with that? If you ever take any number and you raise it to a power, as long as it's a positive number, you can't make that number negative, no matter how hard you try. You can never make a positive number raised to a power negative. And that just goes back to, if you graph this thing, it would always graph like this. It would never go below the x-axis, which is a weird thing, but it's true. The only way to make it go below the x-axis is actually to put negatives in front of these. Is everybody good with that? Which we won't do today. All right. So guys, knowing that, can you guys put these e's in order? It's going to be the same rule. Put these e's in order from smallest to largest. Okay, did you guys get the same thing I got? And it should look a lot like your 3s up here, the bottom row of your 3s. Is everybody good with that? Okay, so we're going to hold that thought and we'll go back to it in a few minutes. But I wanted to make sure that we agree on how to put numbers in order. Okay, now we're going to go to something that seems totally different, but we'll tie everything together in a second. I want to take the derivative of an ln. Okay, please pull out your formula sheets, guys. If you don't have one, you need to get one quickly, because this formula sheet is going to be like your lifeline, okay, as we move through this class. All right. What's the derivative of ln of u? So somewhere on your formula sheet, I think it's the second page top left, okay? But somewhere on your formula sheet, you have the derivative of ln of u. Guys, if you are online, your formula sheet, I gave it to you sometime last week. And so look in your Schoology if you don't have it, but it's in there somewhere. You should print it out and you can use it for your final exam in April if you have everything filled out, okay? Well, even if you don't have everything filled out, you could use it. It just won't be helpful if you don't have things filled out. What you have to know, the new derivative that you're learning today is a derivative of ln of u is actually equal to 1 over u times du dx, okay? That is the derivative of ln of u, okay? Another way to write this, okay, so you should write it both ways on your formula sheet because sometimes one way is easier than the other. Another way to write this is u prime over u. Now, where did I get this u prime from? Well, u prime is the derivative of u. Okay, so all I did was move u prime to the numerator, right? Because remember, guys, numerators can bounce out, right? So if I bounce this numerator out, it's really the same as du dx over u, which is really the same as 1 over u times, if I bounce this thing out, it's times du dx. Okay, numerators can bounce out. They don't bounce down, okay, they just bounce out. Okay, they don't bounce to denominators, what I'm saying. They just bounce out. Okay, so these two blues is what you can memorize. Some people find this one helpful, this red here. I don't use it as much because I feel like it's the exact same as this blue one, but these are all synonyms. They're all the same thing. And sometimes this one's easier than this one, and sometimes this one's easier than this one. Okay, so knowing this formula for the derivative of ln of u, see if this makes sense. I'm going to pull this up a little bit. Okay, so it's not in my way. Okay, so knowing this, okay, and this is actually the same as u prime over u. The derivative of ln of u, see if this makes sense. This is your u, right? The derivative of ln of u is equal to u prime over u. That's the derivative of this, 3x squared plus 5 over u, x cubed plus 5x plus 1. See how easy that is? Maybe it's not easy yet. Maybe we'll do another one and it'll be easy. The derivative of ln of u, if this is my u, so the u is the argument that goes with your ln, is always equal to u prime over u. So it's the derivative of your u, which is negative 2x, over your u, which is 1 minus x squared. Is it getting easier? Okay, so what's the derivative of ln of sine x? It's u prime over u. So it's a derivative of sine x. So you also have to have this somewhere on your formula sheet, hopefully. It's on the front if you want to put it in. The derivative of sine x is actually cosine x, right? So the derivative somewhere on your front sheet, you have the derivative of sine x, sine u actually, is equal to cosine u times du dx. That should be on your formula sheet. Don't forget the times du dx because it's actually chain rule there. Okay, so it's just not cosine u, it's times du dx. So the derivative of sine x is actually cosine x, right, times the derivative of x, which is 1. Is everybody good with that? Divided by this u, which is sine x. Is everybody good with that? So cosine x over sine x. What's another word for cosine x over sine x? Close, not tangent, but cotangent. All right, so this is actually equal to cotangent x if you wanted to simplify it more. All right, and then down here, I'm going to let you do that. What's the derivative of ln of x squared plus x cubed? Go ahead and jot down your answer. We're in your notes, guys, that you guys picked up today. Did you get 2x plus 3x squared all over x squared plus x cubed? Pretty easy, right? Okay. Okay, so somewhere in your notes, you should put down this. The derivative of ln of x is actually equal to 1 over x, okay? You can only do this if this x is positive. You can try it in your calculator. If you put in 0, your calculator will say you have a problem. And if you put in any negative number here, your calculator will say I have a problem, okay? So you can't put in 0, you can't put in a negative number. X always has to be greater than 0. And if you take the derivative of u, the formula is u prime over u. And again, u must be positive for this even to work, okay? Somewhere on your, I think it's on page 4. On page 4 of your notes, okay, you have this formula here, log AU. Can you guys go ahead and fill it in? Because I want to show you something right now, okay? On the 4th page of your notes, the derivative of this is u prime over u, okay? It's the same thing, but you have this extra factor called ln of a. So can you write that in? U prime over u times ln of a. Okay, and that is the generic formula for a log, the derivative of a log. Okay, it's on the 4th page of your notes, not your formula sheet of your notes. So if you look at your notes, go to the 4th page, the stapled white paper you picked up today. You have this derivative of log AU. And it's also on your formula sheet somewhere. Okay, but we'll talk more about this tomorrow. But I want to show you guys this. Do you understand that ln of u, ln, do you guys know that that's really log e? Did you know that? That's why we call it ln, because log e is so common that it turns to an ln, but it really is log e, okay? So this down here is really the generic formula. This is actually a specialized formula, even though we memorize it, okay? The generic formula is u prime over u. Do you see here's a u prime over u, okay? But you also have this factor, the ln of a. So you put here the ln of a. Well, what's my a in this? What's my a here? E. What's the ln of e? We talked about this at the very beginning. When you log a tree, the cat falls out. Where's the cat here? 1. So this is just 1. And that's why I told you that the derivative of ln of u is equal to u prime over u. Okay, it's because there really is another factor here, ln of e. But when you do a log e, that factor goes away. Is everybody good with that? All right, so I mean, I didn't have to explain that to you, but it's helpful to understand that these really are the same formulas, okay? All right, and then somewhere in your formula sheet, or somewhere, you should have, let's see, the ln of u. Wait, is this the same formula? Yeah, okay, so you should have these written down. The u prime over u ln of a can also be written just like you write this one, 1 over u du dx, as 1 over u ln of a times du dx. So there's 2 forms to write this. They mean the exact same thing, but sometimes one way is easier than the other. So if you write them both, then if one way is like, gosh, I don't even understand this, do it the other way and it'll make more sense, okay? All right, so these are all your formulas that you're memorizing today. This one we're not gonna do as much, we're gonna do more of this tomorrow, but this one we're gonna do a lot today. Okay, you guys ready? The other thing I need to tell you is if you ever have to take the derivative of a log with an absolute value, you just pretend that the absolute value is not there, okay? So this is really the same as the derivative of ln of u, okay? So on your homework, okay, I do ask you for a log of an absolute value. I'll say the log of the absolute value of like negative 2x, okay? And guys, you guys are gonna freak out because you'll be like, she never taught me how to do the derivative of an absolute value. Guys, you just pretend like it's not there. This is equal to the derivative of negative 2x. Is everybody good with that? Okay, don't turn it to positive, just like get the derivative without the absolute value. Does that make sense? Okay, and what is this? Because you've done this already. This is my u. So remember, this is u prime over u. Okay, so what's the derivative of negative 2x? Negative 2. What's the derivative? What's u? Negative 2x. So do you see you get basically 1 over x if you simplify, right? Negative 2 divided by negative 2 is 1. Okay. The reason that the negative sign doesn't matter is because if I do a ln of 2x, if I take the derivative of that, do you see that that would be the derivative of 2x, which is 2, over 2x, which also would give me 1 over x, okay? And that's why when you have an absolute value, you'll get the same answer no matter if this inside was a negative 2 or a positive 2, or negative x or a positive x, okay? All right, so absolute values, you just pretend like it's not there and you work the problem. Okay, there are 3 different problems here that look similar, okay, but you do it 3 different ways. 2 of them are on your front page, the black one and the green one on your front page. The red one's on your the back of your second page, okay? So let's look at this black one. If I wanted y prime, that's the derivative of this y, do you see, okay, that this would be the derivative of 4x plus 7. What's the derivative of 4x plus 7? 4 over 4x plus 7. You got that? Okay, what's the difference between that one and this one? This one in the red, which I think is on the back of your page, okay, this one in the red, do you see that there are actually 2 x expressions here? When I have to take the derivative with 2 x expressions, okay, what do I have to implement? Product rule, exactly, okay? So this is going to be the derivative of the first times the second plus the derivative of the second. What's the derivative of ln of 4x plus 7? 4 over 4x plus 7. Don't forget times the first. So if I were to simplify this, this y prime would be ln of 4x plus 7 plus 4x over 4x plus 7. Do you guys see that? And that's simplified here. Okay? All right. One thing I want to ask you guys is please do not cancel these 4x's. You guys good with that? I know you guys like to simplify a lot, but you could only cancel the 4x's if this were a multiplication, okay? The plus sign makes this 4x belong to this 7. They belong to each other. And so we don't break up families in calculus, okay? All right, this final one over here, what's the difference between this and the other ones? Yeah, this one's chain rule. So back to the front page, guys. I don't know why they're in different pages. I mean, I know why they're in different pages, but I don't know why they're out of order. Okay, right here, this is going to be the derivative of, there's a 1 here. Everybody go, there's really a 1 here. Let me put it in a different color. There's a 1 here. So it's going to be 5 times 1. So let me do this one down here. Y prime is equal to 5 times 1. Actually, let me just delete this. Okay. 5. Leave the inside alone. Leave it alone, guys. Take the power down by 1, which is 4. Okay. Then the inside here is ln of 4. I'm trying to put it in a different color. The inside here is ln of 4x plus 7. Okay. Leave the inside alone. That means you just copy. Don't do anything to it. Then multiply by. Do you remember what you multiply by? The derivative of the inside, which is 4 over 4x plus 7. Okay. So that's the answer unsimplified. If I were to simplify it, I would multiply the 5 and the 4. So I would get 20 over 4x plus 7 times the ln of 4x plus 9 raised to the 4th power. And that would be simplified. Okay, you guys good with that? All right, so we're going to have to implement chain rule, product rule, and guess what rule this one is? Quotient rule. Okay, I'll do this one with you, then I'm going to ask you to do the second one. All right, this one here is quotient rule. If I wanted to find y prime, it would be the derivative of the top, isn't that 1 over x, times the second, derivative of the first times the second. Now what sign is this since it's quotient rule? Minus the derivative of the second. What's the derivative of x? 1 times the first, okay? All over the bottom squared. If I simplified this, this would be x over x right here. So that's 1 minus ln of x over x squared if I simplified that, and that's the derivative. Okay, your turn. What's the derivative of ln of x to the 5th? Go for it. It should be 5 times 1, which is 5. Leave the inside alone, take the power down by 1. Leave the inside alone, guys. That means the inside is still ln of x. Multiply by the derivative of ln of x. What's the derivative of ln of x? 1 over x. Okay, it's the derivative of x, which is 1, over u, which is x. So this becomes 5 over x times ln of x raised to the 4th power. Okay, let's do the difference between these two, which is a little bit confusing. But you've got 2 problems here. One where the ln is first, and the second where the cosine is first. I don't know if you see this, but on this first problem, the cosine is the dominating factor, or the dominating function. On this problem, ln is a dominating function. Okay, so on this problem, to take the derivative, okay, you're actually thinking about the derivative of cosine u. On this side, you're actually thinking about the derivative of ln of u. You guys see the difference? Okay, well, let's do it. What's the derivative of cosine u? Negative sine u, don't forget, times what? Du dx. So if you don't have this on the front of your formula sheet, go ahead and add it in. But the derivative of cosine u is actually equal to negative sine u, and don't forget, times du dx. Okay? All right. So what is my u in this problem? U is ln of x. So everywhere I see a u, I'm going to put ln of x. So ln of x goes here. Ln of x goes here. And this right here is the derivative of ln of x. What's the derivative of ln of x? 1 over x. So my answer is, if this makes sense, negative sine of ln of x times 1 over x. Now be careful. This 1 over x can't be multiplied by the ln of x because the ln of x belongs to the sine family. Okay, so you can leave your work like this. It's totally fine. But make sure you understand that if you moved it to the front, this 1 over x, it would be a lot safer because you wouldn't risk accidentally multiplying that by the ln of x. Okay, on the right side, ln of u is going to be the dominating function here, okay? So the derivative of ln of u, do you agree, is u prime over u, right? What is my u in this problem? Cosine of x. Everywhere there's a u, replace it with cosine of x. So what's u prime? What's the derivative of u? Negative sine x. What's u? Cosine x, okay? So what I get here, well, just to make sure you understand, it's negative sine x times the derivative of x, right? But the derivative of x is 1. So there's a times 1 here that I'm not talking about. So this is your answer. But what is sine over cosine really? Tangent, okay? So your answer is negative tangent x, okay? All right, now for the doozy. Okay, guys, why do we learn derivatives? Okay, the reason is because we want to know about how functions are behaving, okay, applications of the derivative. And one of the things they can ask you is, where is y increasing, decreasing, relative max, relative min, okay? When they ask you about increasing, decreasing, relative max, relative min, it's always a first derivative test. Everybody good with that? Okay, when they ask you about concave up, concave down, POI, then it's always the second derivative. You guys good with that? It's actually called the concavity test, but you use the second derivative. Okay, they're asking me about increasing, decreasing. So what I want to do is use the first derivative test. Okay, if I'm using the first derivative test, let me take the first derivative. Okay, what is the first derivative of x squared ln of x? Which rule am I going to use here? Product rule. It's going to be the derivative of the first times the second plus the derivative of the second. Okay, what's the derivative of ln of x? 1 over x times the first. If I simplify this, this would be 2x ln of x plus x. You guys with me so far? All I did was take the first derivative. Guys, I'm going to have to put this in a first derivatives number line. That's the first derivatives test anyway. Okay, the first derivatives number line is where f prime is equal to 0 or dne. Do you remember that? That's where I find all of my critical points. Okay, if I'm trying to find all of my critical points, I set y prime equal to what or what? Do you remember? Equal to 0 or dne. Okay, so let me just write both of them. Okay, the 0 is mathematically the easiest to find. Okay, so let me set this equal to 0. So what I'm going to do is I'm going to try to factor this. What can I factor out of this? Do you guys see? X. So I'm going to take out an x. And the nice thing about taking out an x is I get something times something equals 0. If I have something times something equals 0, what does that mean about one of these somethings? Either x is equal to 0 or 2 ln of x plus 1 is equal to 0. But remember, what I want here is I want my critical points here. I want to know what x values would give me y prime equal to 0 or dne. So I can't just stop here. I need to actually solve for this x, okay? So what I'm going to do is I'm going to subtract 1 on each side, okay? I'm still trying to isolate the x. Any ideas about how to isolate this x? Okay, I'm going to divide by 2, and I'm almost there. How do I pull an x out of an ln? What's the inverse function? E. So what you do is you tree both sides. Okay, you e both sides. It's called exponentiate. So what you get is e to ln of x is equal to e. Let me write it to make sure you understand. E raised to ln of x is equal to e raised to the negative 1/2. That's basically what I did. Okay, as long as you do the same to both sides, you're fine. Okay, they're still equal. Now I'm still trying to find x. So remember I told you if you log a tree, the cat falls out? Well, it turns out if you tree a log, the cat falls out too. Okay, so e to ln, guess what falls out? X. So x is equal to e to the negative 1/2. Now I need to clarify this with you. Even though there's a negative sign here, this is not a negative number. Okay, this is really 1 over e to the 1/2, or you could say 1 over square root of e. Okay, but it's not a negative number. That's going to go in my number line. What other number will go in my number line? Yeah, well, if you put 0 here for sure, but actually all numbers less than 0, right? Because if it were a negative here, all of these would cause this to be dne. What is dne really? It's just saying, look at this expression, which I've totally mutilated. Okay, so let me rewrite this expression. Okay, what will cause this to be dne? If x here is less than or equal to 0, that will cause this to be dne. You agree with that? Okay, but guys, guess what they tell me up here? the x is never less than or equal to 0. Okay, so basically they're saying ignore these critical points. Okay, so what I'm going to do is I'm going to put these two critical points that I have here. I'm going to ignore these critical points because x is always greater than 0, so I don't have to worry about this. X equals 0 and x equals e to the negative 1/2. Now I need you to tell me which one's bigger and which one's smaller. Which one's going to go on the left and which one's going to go on the right? The 0 goes on the left. Even though e to the negative 1/2 has a negative sign, it's actually not a negative number. Okay, so e to the negative 1/2 there, 0 here, and then I'm going to plug in test points, but I don't have to plug in any numbers that are less than 0 because x is greater than 0. Okay, do you remember how to do test points? You go plus, 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 minus, minus, minus. You find a point here, and you find a point here. Now, what I'm going to do is I'm going to find a point and plug it into the y prime. So let me come back here and make sure you guys understand. Oops, this is my y prime right here. Okay, I'm going to try to box it in neatly. So here's my y prime right here, and I'm going to plug into this equation right here. And all I need to know is positive or negative. I could plug into this one here too, but this one, remember we talked about, this one's just a little bit easier to figure out positive or negative. If you want to plug in this, it's fine too, okay? Now, I'm a prophet, okay? So I know that when I plug in here, it'll be a lot easier if I have e to the something. Does that make sense to figure out positive or negative? So let me plug in e to the something. So guys, here I'd like to figure out e to something and e to the something to plug in. And remember what I told you, it's just like the number line. So find an exponent that's less than negative 1/2 and you'll be fine. Because no matter what number you choose, it'll be bigger than 0. Okay, so just think about the number line. And on the number line, oh, I don't have one, but pretend like there's a number line here. If this were negative 1/2, what's the number smaller than negative 1/2 that's easier to like plug in? Negative 1, right? Negative 1 would be a good one. You could also choose negative 2. You could also choose negative 212. Y'all want to do that? Okay, negative 212. Okay, I might do it, but I might not. Let me think about it. Okay, what's the number bigger than negative 1/2? You could choose any number you want because this goes to infinity. What do you want? 212. Okay, let's do 212 on that side. Okay, so what we're going to do is we're going to plug it into this number right here, into this equation. So here we go. Positive or negative. Let's plug in the e to the negative 1 first. I'll get e to the negative 1 times 2 ln of e to the negative 1 plus 1. Okay, remember, I only need to figure out positive or negative. Okay, what is ln of e to the negative 1? It's negative 1. What's negative 1 times 2? Negative 2. What's negative 2 plus 1? Negative 1. So it's a negative number, right? I just need to know negative or positive. E to the negative 1. Now be careful. Is that a positive number or a negative number? It's positive. Even though there's a negative exponent, that's a positive number. So positive times negative is negative. So I've got negatives there. Let me plug in e to the 212. Okay, some people are going to be really mad at calling in a second, but we'll see. Okay, e to the 212 times 2 ln of e to the 212. Actually, this isn't bad at all. Plus 1. I just need to know positive or negative. You guys can see this. Is this going to be positive or negative? Well, what's ln of e to the 212? 212. What's 212 times 2? 424. I mean, 424 plus 1. Yeah, positive. Everybody good with that? Over here, is e to the 212 going to be positive or negative? Positive. What's positive times positive? Positive. So you got negative, 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 positive, positive, positive. And when y prime is negative, guess what y is doing? Decreasing. When y prime is positive, guess what y is doing? Increasing. Okay, so I've really got my answer here. Let me write the answer, see if this makes sense to you. When is y increasing? That's my question. Y is increasing when x is greater than e to the negative 1/2. Okay, don't use your test points. So I'm going to cross out my test points. Okay, your test points you made up. So you can only use your critical points. Is everybody good so far? If I had to justify this, what would be the justification? Because y prime is positive. That's why y is increasing. When y prime is positive, y is increasing. Let's do y is decreasing. Y is decreasing between 0 less than x less than e to the negative 1/2. Do you guys see that interval? You could also do interval notation if you like. Okay, what would be the justification for y decreasing? Y prime is negative. What if I asked you, hey, where's the relative max on y? Here's what y looks like. Where's the relative max? There is no relative max. What if I asked you, where's the relative min on y? Okay, you would say it's at x equals e to the negative 1/2. Well, how did you get that? Because you know this is what y looks like. Does that make sense? And you know there's a minimum right here. All right. And then, guys, what would be the justification for your minimum? Y prime changes from what? Beautiful. Negative to positive. Very good. I've got you on my side. Okay, changes. Any questions about the justification and doing increasing and decreasing? All right. Remember you guys hated that unit? It's pretty easy. You like it? Okay. You're about to have a whole bunch of people charge at you. Okay. Right here, guys, you're also going to have to do on your homework tangent line. Okay. All these things are coming back. Okay. How do we find a tangent line? What two things do you need when you find a tangent line? Point and, okay, so write that down. Okay. And I always give you partial credit if you've got a number for the point and a number for the slope. Okay. So please don't leave it in X form. Please give me a number. So let me find a point. Do we know a point? 1, 3. Okay. I want the slope of a tangent line. When I say derivative, you say slope of a tangent line. What's the slope of a tangent line? It's a derivative. Okay. So this, do you see, is the derivative of x, which is 6x minus, oops, what's the derivative of ln of x? 1 over x. All right. Guys, if this is a slope, I cannot use the x's. The x's are useless to me. I need a number for the slope. How do you get this into a number form? Plug in what, though? 1 or 3? 1. Guys, do you see here my x is equal to 1? Okay. That means everywhere that there is a x, put in 1. And do you see I get the slope is 5? Okay, can you guys go from here and write the equation of a tangent line? Do you remember how to do it? Y minus y, so this is my x and this is my y minus y is equal to the slope times x minus x. Can you guys do that? We've already tested on this. Okay, this is your answer. I would accept this answer. My math lab might be picky. They might want you to add 3 to both sides. Okay, that's probably all they want you to do. But if you had a multiple choice, you might have to know that you have to distribute. You might have to distribute and actually add. Okay, if you had a multiple choice, and I think your test is all multiple choice. Okay, your next test. Okay, that's because I want it to be graded easily. But you guys know multiple choice means. It means all wrong or all right. Okay, so most of you guys will be all right, but that was a pun that didn't work. Okay. Guys, look at these log rules. Can you guys go ahead and copy down these rules here? Log A times B equals log A plus B. Log A over B equals log A minus log B. And log A raised to the B power is actually B times log A. These are all log properties in your notes for today. Okay, how is this useful? This log, if you don't have a number, just FYI, do you guys know that that's really log 10? Do you guys know that from something? I don't know. I don't know how I know it, but if you don't have a number, it's log 10. What this is saying is that if I had 2 logs, like if I had log x squared times the square root, I don't even need the times here, so x squared square root of 3x minus 2, okay? Do you see if there's multiplication here? 1 log multiplication equals 2 log summation. Did you hear the rhyme? 1 log multiplication, you have 1 log multiplication, that's equal to 2 log summation, okay? And likewise, if you have 1 log fraction, so if I had a fraction over here, that is equal to 2 log subtraction. Whoa, that took me a long time to think of. Okay, so 1 log multiplication is 2 log summation, and 1 log fraction is 2 log, you have to remember the rhyme though, subtraction, okay? This right here, I couldn't think of a rhyme, but anytime you have an exponent with a log, this exponent can move to the front, okay? Now I need to explain to you guys, if you guys look in your notes, I have some things that I've crossed out. Okay, and I want you guys to understand that even though it rhymes, it may not be right. Okay, so you have some blanks on the top. It looks like a line, but it's not a line, it's blanks. Can you put 1 log fraction equals 2 log subtraction in your blanks? Okay, it looks like a line, but it's not a line. They're blanks in your notes. So write 1 log fraction in one blank and 2 log subtraction in another blank. And I need you guys to see that this is 1 log fraction, but it's actually not, the property doesn't happen. You have to have 1 log, the log has to be like outside here. It has to be 1 log fraction. The fraction can't be just part of, it can't just be the numerator that's a log, it has to be both, okay? And then this is 2 log fraction, so this doesn't even apply. This is 1 log subtraction, which is not the same thing as 1 log fraction. Everybody good with this? So this is not log properties. This right here is log properties. 1 log fraction equals 2 log subtraction. Do you see that? So on your paper, you have A, B, C, and D. Can you look at that and tell me which one's right? Which one am I applying the log properties correctly? 1 log multiplication. Oops, we're on 1 log fraction. Look on the bottom one, sorry. Your bottom one down here is what we're doing. 1 log fraction, sorry, equals 2 log subtraction. We're on the bottom one. So 1 log fraction equals 2 log subtraction. A, B, C, or D, which one's correct? 1 log fraction equals 2 log subtraction. It's D as in dog, okay? And then let's look at the top one, part A, where we're doing 1 log multiplication equals 2 log summation. And once again, just because it rhymes, it doesn't mean that's true, okay? So this is 1 log multiplication. This is actually 2 log multiplication. This isn't what we're talking about. This is 1 log, but it's only being multiplied by it's only being affected to the top. You need a multiplication where these two are multiplied together. Okay, so this actually, the parentheses needs to be here, not where it was, you know, not just here. So this one's not 1 log multiplication, even though it is 1 log and there's a multiplication. Okay, this one's 1 log summation, so this is not 1 log multiplication. This is 1 log multiplication. Do you see like how it works? And 1 log multiplication equals 2 log summation. So if you look at your top thing on your notes, which is true, A, B, C, or D? Yeah, it's D again in dog. Okay, everybody good with that? So I wanted to clarify that to make sure you guys understand. So we're going to do this problem at the bottom, and I'm going to show you why log properties is kind of nice, okay? All right, so let's look at this problem here, okay? If I had to take the derivative of this, okay, do you see that the derivative of this, okay, is actually equal to u prime, so let's see, the derivative of y is equal to u prime over u. This is my u, right? So it's u prime over u. Is everybody good with that? Okay, so what I'm going to have to do is take the derivative of this and put it on top. Okay, do you see if I take the derivative of this, it's like a quotient rule and a product rule and a stomach ache all rolled in one. Do you guys see that? It's terrible, okay? So when you see something like this that's so terrible, think about this. 1 log fraction equals what? 2 log subtraction. Okay, so this, before I even take the derivative, okay, 1 log fraction equals 2 logs subtraction. So it's x squared times x, the square root of x cubed minus 5x plus 7 minus ln of x squared plus 3x raised to the 4th power. Right? 1 log fraction equals 2 log subtraction, right? Guys, I don't know if you see it. Do you see this one right here? This is 1 log what? Multiplication. But remember, 1 log multiplication equals what? 2 log summation. So you can split this up even further. Okay. And then I'm going to suggest something that you don't have to do, but it does make things easier if you see it. And again, you don't have to. Do you see this 2? You could bring it to the front, right? Because remember, if you have a power with a log, you can bring it to the front. Now, not the very front, okay, just in front of the log. Okay, so it's 2 ln of x. This power here, what power did it really have? 1/2. So you can bring this power, it's still a plus sign, 1/2 ln of x cubed minus 5x plus 7 okay? Where did I get this 1/2? Because this is really raised to the 1/2 power. Okay, I can move it to the front of the log, not to the very front. Like some students will pull it to the very, very front. No, it only pulls to the front of whatever log that you're working with. Okay, and finally, this power here, the 4, okay, is still a minus, so -4, but you can pull it to the front of the log. Okay, just the front of the log, not just anywhere. Okay, everybody good so far? And remember, what did I have to begin with? I had to take the derivative of this big old thing, okay? And I haven't even taken the derivative. But this 1 log fraction equals 2 log subtraction. And so I've rewritten it so instead of taking the derivative of 1 problem, okay, I thought I got to take the derivative of 1, but guess what? Oh boy, I get to take the derivative of 3 problems, okay? But these 3 are way easier. Do you see that? I avoided having a conniption fit, okay, by changing this with using log properties. Because guys, what's the derivative? So let me go with y prime now. What's the derivative of 2 times ln of x? 2 times what? Not 1/2, 1 over x. Does that make sense? Okay, keep moving. What's the derivative of 1/2 times ln of this? It's 1/2 times, what's the derivative of ln of this? 3x squared minus 5 all over what? X cubed minus 5x plus 7. Nice, right? Okay, what's the derivative of -4 ln of u? It's -4 times, what's the derivative of ln of u? 2x plus 3 all over what? X squared plus 3x, okay? And this is my answer. You can simplify this, but I'm good with you stopping here, okay? Did you see that was way easier than taking the derivative and the product rule and the quotient rule and all that of the very top, okay? So when you're in a quandary on your homework and you're like, boy, this is so hard to take the derivative, it's because you need to use log properties, okay? So why don't you guys turn to the back of your notes, do this problem here, and then you guys can start working on your homework, okay? So do this problem here, ln of the square root of 3x minus 1. Take the derivative of that, and I'll do it with you guys. Chris is doing it right. You could do product rule. It would work, okay? But do you see it's 1 log multiplication, right? And 1 log multiplication is really 2 log summation. Oops, not y prime. This is still just y. Did anybody get the 1/2 up there? What can you do with that 1/2? Okay, move it to the front. Not the very, very front. Just in front of that log that the 1/2 belongs to. Do you guys see how easy this is if you use log properties? Okay, if you don't use log properties, you're doing product rule, and I don't know what else you're doing, but it's a lot harder. Okay, did you guys get the same thing I got down here? Okay, then you're in good shape. Go ahead and do your homework. What you'll do today is not all of your homework. Can I see your paper, Travis? You're going to do 1 through 5. You do 1 through 5, and then you'll do 11 through 19. 1 through 5 and 11 through 19. Okay, and that's what you do tonight. Guys, I would not wait until tomorrow to do all this. Just like your optimization, if you wait, you'll find that you're going to be falling behind. Okay, so 1 through 5, and then now I forgot the numbers. 11 through 9. 11 through what? 19. 11 through 19. Okay, the test is next Tuesday. So we'll work on this for 2 days. Then we're going to do the derivative of e to the u. Then we'll do the derivative of a to the u, and then by Thursday you'll have everything you need to know for the test. Friday I'll give you the review. It's going to be on my math lab. and then you guys would do the review, and then you can work it through the weekend. If you know the review, you're ready for the test. Okay, the test is on Tuesday. So those of you guys who are in band, if you feel comfortable with the review, you're free to test on Monday. If you're not, then you're free to test on, I guess that'd be Wednesday. Okay, guys, we want to take the derivative of this. This is number 2. Guys, make sure you understand, this is not 1 log fraction. Everybody good with this? 1 log fraction would look like this. Okay, so this is not 1 log fraction. This one is actually quotient rule. Do you see it? It's the derivative of the top, okay, times the bottom, minus the derivative of the bottom times the top, all over x to the 5th quantity squared. Okay, so if I simplify this, I would get x to the 4th, this is the first term, minus 5x4 ln of x, which is all I have here. The bottom, what do I do if I have a power to a power? Do you remember? Do I add or do I multiply? You multiply, so this is x to the 10. Okay, you're probably going to want to, is this a multiple choice problem? You're going to have to simplify. So you're going to factor out x to the 4th on the top, x10, and then this x10, x4th, you're going to have to simplify that. I think you can take it from there. Derivative of ln of 5x. You agree with that? Now, what's your u? This is your u, right? What's the formula? It's u prime over u. So plug in. If this is your u, what's the derivative of ln of 5x? Just do it on the side. The derivative of ln of 5x is 5 over 5x. So that's equal to u prime, right? Okay, so u prime is now 5 over 5x. What's your u in this problem? ln of 5x. So there's your answer. 5. Oh, dividing fractions easiest pi, flip the second and multiply. Or, do you remember what I told you about numerators? They bounce out, okay? So you could just say numerators bounce out, and that's your answer. And one of those answers should be right. Oh, you have to reduce the 5 over 5? Is that it? Okay, yeah. So the answer should be 1 over x times ln 5x, something like that? Okay.